String, in, function, a less known function in Googology. Consider this sequence. 1, 3, 27. What do you think will be the next term in this sequence? 81, 243, 729. Let's say even 19,683 or 76255974849847. If you were thinking in that way, then you are wrong. The next term in this sequence is extremely large, it's beyond anything what we could have imagined and is already much larger than a Google. Now you would be thinking, which function is this? This is the string, n, function, a less known function in Googology. In fact, this is so less known that it does not even have a fixed name or a fixed definition in the mathematical community. A post in Reddit made about 8 years ago mentions this function as seq, n. And another post in Mathoverflow around the same time mentions a similar function as strn, where the empty string is also being counted. Harvey Friedman in his paper Long Finite Sequences, published in the year 1998, also mentions this function as fk. Fk is the same as string n plus 1. Harvey Friedman also proved that this function will be finite for all values of n. Understanding the string n function gives an idea as to how the related functions like tree n, sscgn, scgn, etc. will be finite and how those functions will eventually terminate. Now, what is string n function? Consider an alphabet with n letters. String n denotes how many strings we can create, where any kth string is of length at most k such that no string contains a previous string. These are the rules for string n. 1. We can use n different symbols for string n. 2. Length of first string can be 1, second string can be 2, and so on. 3. The string n function terminates if a string contains a previous string. In mathematical terms, we can say that the function will terminate if a string is a supersequence of a previous string. By contains we mean that if we have a string like AA earlier, we can't have a string like a star. A star here means any string. Remember the sequence 1, 3, 27 we mentioned at the beginning of this video. They are the values of string n for n equals 1, 2, 3, and so on. Let's calculate string 1. We can have only one character A and the only string we can create is A. So that gives the value of string 1 is equal to 1. If we try to create another string, then that string will be a supersequence of A and it won't be valid. Now coming to string 2. We have two characters A and B and we can start with A again. Now we have the character B left and we can create the string BB. Now at third go we can create the string B. After this we cannot create another string. We get the value of string 2 is equal to 3. String 3 is what makes this function interesting. The value of string 3 is 27, and here are two of the ways we can reach 27. Both these sequences show how the string n function terminates. A similar termination could be seen in tree n, sscgn, scgn, and other related functions too. Now coming back to the original sequence 1, 3, 27, mentioned at the beginning of this video. The next value in the series is string 4. And the value of string 4 is greater than half multiplied by 2 up arrow 7198. 158,386 is shown by Harvey Friedman in his paper, whose link is being given in the description. Up arrow here represents noth up arrows. And the value of string 5 has been shown to be greater than Graham's number. How is string 4 so massive? Let's try creating the strings. This isn't the optimal route and we can do better. Still we can go like 1A, 2BB, 3CBC, 4BCCC, 5BCC, 6CDCDCB, and so on. 17th string will have 17 Cs and 32nd string will have 2 Cs. As we can see, the Cs will keep reducing one by one with every new string. 33rd string will be BDC followed by 30 Ds, and 61st string will be BDCDD as we reduce the Ds one by one. Then we can have 62nd string as B, followed by 59 Ds and then CD. By reducing the Ds with each step, we get the 110th string is BDCD. Now we can see where this is going. And this is not even the optimal answer, and still we can see that string 4 is greater than or equal to 3286970409. Harvey Friedman showed that string 4 is greater than half multiplied by 2 up arrow 7198. 158,386. This string n function shows the beauty of mathematics, that how with an easy to explain function and a sequence which grows like 1, 3, 27. We can end up reaching astronomical numbers in the range of noth up arrows with just 4 symbols. This is our submission for #SOME4. Hoping you enjoyed the video.